Okay, section C, graphing externalities. Let us graph how the award of damages can internalize an externality and restore efficiency. We assume that a firm like Atlantic Cement is liable for the external costs it inflicts on others. The situation facing the firm is in Figure 5-1. See Figure 5-1. The incentives to adopt a new superior technology under a rule of temporary damages. There's a graph with the horizontal axis from 0 to Q and a vertical axis from 0 to dollars. And there are different quantities on the horizontal axis, Q sub 1, Q sub 2, and Q sub naught. And there's a price point of capital P sub naught and the marginal social cost, the marginal social cost prime, and the marginal private cost, all emanating from point capital A on the vertical axis from 0 to dollars. Back to the text. The company's marginal private cost, capital's MPC, indicates the private cost to the firm of producing different quantities of cement. Private costs include capital, labor, land, and materials, but not the external harm caused by pollution. The external costs of pollution are added to the private costs to yield the social cost of producing cement. Figure 5.1 depicts two marginal social cost curves representing two different technologies. Under the old technology, the addition of external cost of pollution to the private costs of production yields the marginal social cost curve, capitals MSC. This curve depicts the true cost to society of each level of production under the old technology. There is, however, a new technology that pollutes less. Its marginal social costs are shown along line capitals MSC prime. The superiority of the new technology lies in the fact that it causes half as much pollution at any given level of output as the old technology. For example, the old technology might use filters in the smoke stack, and the new technology might use scrubbers in the smoke stack. Under either technology, and in the absence of any court or regulatory action, the company's profit maximizing rate of output, Q sub naught, is determined at the intersection of the private marginal cost curve and the prevailing output price, capital P sub naught. Under the old technology, the total amount of external cost inflicted by the output rate is Q sub naught, is the area A, B, C. Under the new technology, the total amount of external cost inflicted by the output rate Q sub naught is the area A, B, D. The net social cost inflicted by the last unit of output is T prime plus T under the old technology and T prime under the new technology. Note that it is easy to see here that even if there is no legal compulsion for the firm to take external costs into account, society is better off if the firm is producing under the new technology rather than the old technology. However, if the firm is not required to internalize these costs, it has no incentive to adopt the new technology. However, matters change if the firm can be made to internalize the social cost of its production of cement. Under the old technology, and with the firm held responsible for its external costs, the profit maximizing rate of output is determined by the intersection of capital P sub naught and capitals MSC at quantity Q sub 1. At this point, the cost of pollution is area capitals AEF. But under the new technology, and with the firm held responsible for its external costs, the profit maximizing rate of output is determined by the intersection of P sub naught and capitals MSC prime at Q sub 2. Social efficiency requires the firm to adopt the new technology and produce at Q sub 2. Can you identify the cost of pollution at production level Q sub 1 under the old technology and at Q sub 2 under the new technology? Superscript 62. It reads, at Q sub 1 under the old technology, the cost of pollution is capitals AEF. At Q sub 2 under the new technology, the cost of pollution is capitals AGH. Again, see figure 5.1. But what about the firm? It is indifferent between the two technologies. No. Is it indifferent between the two technologies? No. Assuming that the firm pays pollution costs, its maximum profits under the old technology are the area capitals A, P sub naught F, where maximum profits under the new technology are capitals A, P sub naught H. It's obvious that capitals A, P sub naught H are greater than capitals A, P sub naught F. How do these considerations relate to the question we asked above about the incentive for adopting superior technologies of production under the alternative damage measures? The intuitively plausible answer is that the cement company will adopt the cleaner technology more quickly under temporary damages than under permanent damages. And that intuition is borne out by our formal analysis. However, these economic advantages to temporary damages over permanent damages must be balanced against the potential administrative costs of temporary awards. Question 5.37. The price line, capital P sub naught, is horizontal in figure 5.2. What does this fact indicate about competition? Questions 5.38. Assume that science reveals a new health hazard caused by breathing pollution from cement factories. How would such a discovery modify the graph and it change the efficiency level of production of cement?